My interest in science goes back over 3/4 of a century. When I was quite young, just going into the 4th grade, I got a chemistry book and became very, very much interested in chemistry because in the back of the book there was a periodic table of the chemical elements. And I fell in love with the chemical elements, so first thing I did was work on memorizing the periodic table of the elements, which was quite different than it is now because there were so many elements that had not yet been discovered. But we had just arrived in California, and shortly after that, Christmas arrived, and I received a microscope for Christmas. That was an incredible event because at that time we had no television, we had a radio, but my microscope was a window into an astonishing world. I could go and take a drop of water from a pond and put it under the microscope on a microscope slide with a cover slip on and sit there and watch in wide-eyed amazement as diatoms would gracefully swim across the field of view, as rotifers would come along and vorticelids and gobble up these poor helpless little plants that were moving around in the field of view. It was like having your own personal zoo. So that really began my excitement about microscopy and the study of the microworld. A few years later, when I was in the 8th grade, I got a telescope and had an opportunity to look at the craters on the moon and to see the moons of Jupiter and the rings of Saturn. And at that point in time, we had moved to Clarksville, Arkansas, and I was in the Scouts as an explorer, and my scoutmaster was Dr. I.T. Beach, Irving T. Beach in Clarksville, Arkansas. And this was amazing because Professor Beach was professor of chemistry, head of the chemistry department at the College of the Ozarks. Well, here I had a chance to actually get to know and talk to a real scientist. This was the first scientist that I had ever had an opportunity to know. And to me, that was like someone interested in acting, getting to know John Wayne or Katharine Hepburn, because his passion was my passion. In fact, I would go over to the College of the Ozarks and spend time there washing the Erlenmeyer flasks and the beakers, and Dr. Beach allowed me to buy chemicals from the College of the Ozarks, and so I set up my own chemistry laboratory. I had gas and a Bunsen burner and did all sorts of chemistry experiments and had tremendous fun learning chemistry. So basically, this interest in science goes back to the very, very earliest memories that I have. Of course, one of the other things that happened was in 1957, there was an amazing event that occurred, and that was the launching of the first Earth satellite, Sputnik 1. And Professor Beach and I, when we heard of this, we went out to the quad of the College of the Ozarks there in Clarksville, Arkansas, and we lay on the grass and watched as Sputnik 1 came over. It was an amazing time. The planet Earth had entered the space age. And so this inspired in me not only a love of chemistry, but a love of physics and an inspiration to study everything I could about rockets and rocketry. And of course, shortly after that, we had the launch of Explorer 1, and Wernher von Braun became one of the most famous people on Earth. Dr. von Braun was my hero at that point in time. And in fact, I have to say, throughout my entire life, Wernher von Braun has been my hero. And at that point, I never envisioned that there was any possibility that I might ever get to meet such a great man. But I continued my studies and then became extremely interested in mathematics and in relativity. So I decided when I was in the 11th grade that what I should do was devote my life and my career to the study of the origin and nature of the universe. So I wanted to become a cosmologist. Therefore, when I went to Henderson State University, I concentrated on studies of physics and of mathematics. And my degree was with a triple major in mathematics, physics, and French, and a minor in chemistry. And shortly after I graduated, I went to Duke University because I wanted to study relativity. So I went to Duke University on a National Science Foundation grant and spent the entire time there translating a book by Nikolai Bourbaki from the French into English, and this was a theoretical development of tensors. My professor was very much interested in this, but he didn't speak French, so he wound up getting a copy of the book in English, and I struggled to make my way through the mathematics, which was incredibly difficult. After that, I was at the University of Arkansas, and I was doing work on X-ray diffraction, and all of a sudden I went with a friend of mine to the campus on one Sunday afternoon, and there was a booth set up there, and I wandered over because it had a big NASA banner in front of it. And as I was talking to the people and they found out what I was doing, they asked if I would be interested in coming to work at NASA. And I thought this would be exciting but impossible. And so I took the civil service examination, and shortly after that I got a phone call from Norman Horkmeyer, who was in charge of employees at the Marshall Space Flight Center, and I was offered a job to come to NASA. I went and I was teaching a course for my major professor, and told him I would like to know if I could leave the University of Arkansas and go to NASA at the end of this course that I was doing. And he said, well, you have to. And I said, I have to? He said, yes. He said, if you're so stupid you don't take an offer like that, you're too stupid to teach any kind of course in physics here at the University of Arkansas. Of course, I had also mentioned that they were offering me $7,500 a year, and at that time I was making $1,200 a year as an assistant teaching this course in elementary physics. So I left the university in February of 1966 and came to Huntsville, Alabama, and joined the Marshall Space Flight Center. I was immediately told that Dr. Von Braun, because I had been working on X-ray diffraction, had decided that instead of working on fluid and flight mechanics, which I thought was what I was going to be doing, that they wanted me to go to Astronautics Laboratory to work in optics. Well, I was perfectly delighted to do that because that was much closer to what I'd been doing at the University of Arkansas. So when I got there, my first division chief was a wonderful man by the name of James C. Taylor from Texas. Tex Taylor was the division chief of the Applied Research Division of the Astronautics Laboratory at Marshall. And one of the first things that Tex Taylor told me is that if I was going to be working in optics, I needed to know how to make and measure optical components. So the first job he gave me was to build a 6-inch diameter Cassegrain telescope. And to do that, I was given the assignment of making by hand a paraboloid, and was told that I should make this paraboloidal mirror to a 20th of wave in visible light. So I went into our dark room. I went down and got Andy Crutcher and Charlie Hawkins to help me make a pitch lap, and I started grinding a Pyrex mirror, 6-inch diameter Pyrex blank, grinding it first to a sphere, and then start polishing it, and then going to making it into a paraboloid. All of this done by moving the pitch lap across the surface of the mirror with different grades of grit and polishing compound. And I spent about 6 months polishing, and as I got closer and closer, I learned how to do things like the Ronchi test and the Gabiola caustic test to measure the figure and characteristics of the mirror. And it was taking so long because I would polish for about 30 seconds and then go and test the mirror and then go back and polish another 30 seconds. And I decided this was too slow, so I polished one time for about 3 minutes and went, and all of a sudden my interference fringes didn't look right. And my supervisor, Darrell Evans, came, and I said, "What's wrong here?" And he said, "Well, what's wrong is you rolled the edge of the mirror." And I said, "What does that mean?" He said, "Go back to the number 100 grit," which is where I had started. And so I was devastated because now I had to start all over again and remove all of my work. But by that point in time, I was a lot better at polishing and grinding and knew what I was doing. So it only took me a couple of months to get back to where I was before. And finally, I came and presented to James Taylor and my branch chief, Joe Randall, the mirror that I had prepared, and they came and looked at the measurements that I had made and verified that I had actually achieved 20th wave in visible light. Well, actually it's kind of fascinating because that's somewhat reminiscent of the way Dr. von Braun began his career. When he was very young, his father, who was a baron, very wealthy, a member of the Hindenburg administration. In fact, he was Secretary of Agriculture, or in charge of the Agriculture Department in Germany. He decided that his young son should learn the value of money, and so Dr. von Braun went to work for Krupp, who was the great steel magnate in Germany. And von Braun tells a story about how his first job was quite similar to my first job. He went in and Krupp gave him a big lump of steel about the size of a human head, and gave him the instructions that he was to take a file he had given him and bring him back a perfect cube. So von Braun relates to how he took this big lump of steel and he started filing and filing, but the problem is that a cube has to have all of the sides exactly the right length, and all of the angles at every one of the corners has to be exactly 90 degrees. So you got 3 90-degree angles of each corner at the 4 corners at the top, and 3 90-degree angles at each corner at the 4 corners of the bottom. And all the sides have to be precisely the same length. To do that with nothing but a file. And von Braun recounts as how many months later he finally returned to Krupp and handed him in the palm of his hand about a 3 centimeter diameter, a little more than an inch in size, a cube, which Krupp then accepted as being the solution to the problem he had given him. So it was indeed wonderful to have an opportunity to be working here at the Marshall Space Flight Center because this was in 1966, and the director of the Marshall Space Flight Center was Dr. Wernher von Braun, and he and the many thousands of people that were working at Marshall at that time were working furiously for the development of the Saturn series of moon rockets, the Saturn I, the Saturn 1B, and ultimately the Saturn V, that would carry the first human beings to the surface of the moon on the 11th of July 1969, when the landing occurred on July the 20th, 1969. I had a number of opportunities to meet Dr. von Braun personally, and he was every bit as much a hero of mine when I started working for him as he was when I absolutely admired him as a young child. And it's a great pleasure to be sitting here at the Davidson Center of the United States Space and Rocket Center. I'm sitting in front of the simulated office of Wernher von Braun, and it's very intriguing because it looks very much like it did when I first met Dr. von Braun in 1966, a few months after I had arrived to work here at Marshall. There was a bookcase and the various rockets that Wernher von Braun had developed, starting with the V2, which we have over my right shoulder here, all the way up to the Saturn V, and I'm sitting here under the magnificent F1 engines of this Saturn V vehicle, which, by the way, happens to be one of the first Saturn Vs that was manufactured, first stage manufactured here at NASA Marshall Space Flight Center.